What makes your pancreas able to regenerate? Imagine your pancreas as a resilient organ with a surprising ability to heal itself, but how exactly does that work? The key lies in its capacity to regenerate through the replication of existing cells, especially in its two main parts. The endocrine part, which produces hormones like insulin, mainly regenerates by the division of mature beta cells. These cells can replicate themselves, helping maintain or even increase their numbers after injury or in response to increased demand. This process is supported by studies showing that new beta cells mostly come from the division of existing ones, rather than stem cells or other progenitors. The exocrine part of the pancreas, responsible for making digestive enzymes, also has some regenerative ability. When injured, acinar cells, which produce these enzymes, can proliferate to replace damaged tissue. Interestingly, these cells can also change their identity temporarily, dedifferentiating into a more primitive duct-like state before redifferentiating into acinar cells again. This cellular plasticity helps repair the pancreas but also raises questions about how this process might go wrong, especially in the context of pancreatic cancer. However, the idea of creating new beta cells from stem-like progenitors in adults is still controversial. While embryonic development involves progenitor cells marked by specific genes, activating these in adults is challenging and not well established. Some research suggests that reactivating embryonic pathways could generate new beta cells, but this remains an area of ongoing investigation. Several molecular pathways influence pancreatic regeneration, including hedgehog, Notch, and Wnt signaling. These pathways help regulate cell growth and differentiation. Transcription factors like NR5A2 and PT-F1A are essential for maintaining acinar cell identity and promoting regeneration. For beta cells, scientists are exploring targets like DIAC1A inhibitors, which can stimulate their proliferation in experimental settings. But translating this into safe, effective treatments requires careful control to avoid risks like tumor formation. It's also important to recognize that regenerative capacity varies among different species. For example, rats can regenerate acinar tissue quite effectively, while mice show less robust regeneration. This variability makes it more complex to apply findings directly to humans, but ongoing research continues to shed light on these processes. Understanding how the pancreas regenerates is vital for maintaining pancreatic health and addressing conditions like diabetes and pancreatitis. While the organ can repair itself to some extent, the cellular plasticity involved in regeneration can also pose risks if control mechanisms fail, potentially leading to abnormal growth or cancer. Supporting pancreatic health involves maintaining a balanced lifestyle, managing blood sugar levels, and avoiding excessive alcohol or smoking, which can impair regenerative processes. Always remember, individual health varies, so if you have concerns about your pancreas or are managing a health condition, consult a healthcare professional for personalized advice.